will put air inside this balloon. Just like that, para magkasya siya dun. Right?
According to gas law, the volume of a gas at constant pressure is directly proportional to the absolute temperature. Also, Charles' law is an experimental gas law that describes how gases tend to expand when heated. This experiment is an example of a Charles' law because it shows how temperature affect the volume of the balloon. As the temperature decreases, the volume of the balloon decreases too.
When a candle burns inside a cup, it heats the air, causing it to expand. When the flame goes out, the air cools and contrasts, lowering the pressure inside. Gay-Lussac's law relates pressure and temperature, showing that as temperature drops, pressure decreases. The higher external pressure pushes the water into the cup to equalize the pressure difference. Gay-Lussac's law defines the correlation between the pressure of a gas and its temperature, while the volume remains constant. This principle was developed in 1808 by a French chemist named Joseph-Louis Gay-Lussac. He stated that if you have a certain mass of a gas and its volume is maintained, then the pressure of the gas will always be directly proportional to the temperature of that gas in Kelvin. A simpler way to explain is that if you take a gas-filled sturdy container and heat it condense, the pressure of the gas will increase. On the other hand, if the gas is cooled, the pressure will drop. In candle, water, and glass experiment, the air inside the glass gets heated by the lit candle. This leads to an increase in air pressure. Once the candle goes off, the air pressure starts to drop since the air cools down. The low pressure subsequently enables water from outside to go in the glass. This process effectively demonstrates Gay-Lussac's law, which states that the temperature and pressure of a gas are directly proportional when the volume is constant.
Ideal gas law can be demonstrated with a simple and practical example. So we demonstrate balloon expansion with heat. But before that, we needed some material like a balloon, a bottle, a hot water, and cold water. Before that, we need to follow the instruction. So first, inflate the balloon slightly to stretch it and then place it over the neck of the bottle like this. And after that, place the bottle in a bowl of hot water so we observe the balloon is expanding. As the bottle is placed in hot water, the temperature of the air inside increases. Since the number of moles of gas and volume are constant, the pressure inside the bottle increases, causing the balloon to expand like this. And after that, transfer the bottle to a bowl of cold water so we observe the balloon deflating. Ayan. Tumalambot. Like this. Pawalan siya ng hangin sa loob. Pag inikot-ikot pa to. Ayan. So, when the bottle is placed in cold water, the temperature decreases, reducing the pressure and the balloon deflates. Like this. Nawalan siya ng hangin sa loob. So, this experiment visually demonstrates the relationship between temperature, pressure, and volume in the ideal gas law. Okay?
The ideal gas law can be demonstrated with a simple and practical example. As the bottle is placed in hot water, the temperature of the air inside rises. Since the number of moles of gas and volume are constant, the pressure inside the bottle increases, causing the balloon to expand. When the bottle is placed in cold water, the temperature decreases, reducing the pressure and the balloon deflates. This experiment visually demonstrates the relationship between temperature, pressure, and volume in the ideal gas law.
This is for Boyle's law experiment, but with the whole experiment. Air pressure and surface tension of the water work together to keep the water in the bottle despite the hole in the bottle. And then the air is given a path to get into the bottle and will act with gravity to push the water out of the hole. When the bottle is squeezed with the cap still on, the pressure inside the bottle also overcomes the pressure pushing on the outside of the bottle and allows the water to spray out of the hole. So let's try. Boyle's law states that the pressure of a gas is inversely proportional to its volume when the temperature is constant. This principle can be observed in a simple experiment using a bottle filled with water and some trapped air. When the bottle is squeezed, the volume of the trapped air decreases, causing its pressure to increase. This increased pressure pushes down on the water, affecting the movement of objects inside the bottle. When the bottle is released, the air expands, decreasing the pressure and allowing the water and objects to return to the original position. This experiment demonstrates how changes in air volume influence pressure, a principle applied in real-world scenarios such as deep sea diving and hydraulic systems.
Ito mo bakit ito? Pero ito pakita sa video. Bakit? 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 Oh. Ay, bakit na yun?
Mangat na. Kailan na
Hindi lang. Ito mga ito.
Ito sa mga. At may malit na egg. Mga nakabog! Ayun mga guys. May bilog. Uy. Bakit? Oo. Kaya ako bakit? Yun na yun. Hindi. Yun na. Yun na. Ah, tinawag na. Hindi ko alam. Sabi niya nanti. Mangat. Woo! Go, go, go. Bumabog. Ikaw ko mangat. Uy. Baka stuck ulit. Baka may stuck.
Kita ko sisi mo.
Shadow mo. Ba't ka nanginginig? Nanginginig. Ba't nanginginig mo siya?
Minsan, ano mga?
Fourth. Ano ka doon?
The combined gas law is a gas law combination of Boyle's law, Charles' law, and Gay-Lussac's law. It describes how pressure, volume, and temperature relate to each other for a given amount of gas. In our egg in a bottle experiment, it shows combined gas law. As you can see, the bottle is full of air molecules. When we put the burning piece of paper inside of the bottle, it increases the temperature inside. When the air is heated inside the bottle, the molecules will move faster and spread apart. Once the pressure inside is strong enough, it allows some air to escape and reduce the number of molecules inside. When the flame extinguishes, the air inside the bottle cools down, reducing its volume and pressure. The pressure outside the bottle is higher than the outside of the bottle. Now, the force outside the pressure exerts to the egg is enough to push the egg inside through small opening of the bottle. Now, its opposite effect occurs when removing the egg inside of the bottle. As you can see, as we heat the air in the bottle, the pressure inside gets much higher than the pressure outside. The higher inside pressure generates a much stronger force than the pressure outside of the bottle, causing the egg to push outside of the bottle, allowing the air to rush out, balancing the pressure inside and outside of the bottle.